Hi, this is Suchi and I'm back with another video in the NumPy series. So in this video, I'm going to talk about the search method in an n-dimensional array. So before doing that, what we need to do, as always, we need to import the NumPy package in our code so that we can use all its methods and classes. And here we are assigning a small name so that we do not need to call it NumPy every time. We can call it in. So if we run this cell, what will happen? In our code now, NumPy library is available, NumPy package is available with the name NP. Now let's get into the example. So what is our aim? Here, this is the, just consider this as an array. An array that is named fruits, and this is having some string values here, which are nothing but fruit names. Now we want to know if a particular fruit is present in this array or not. If it is present, then at which index it is present. For example, if we want to search for apple, so at which index or indexes the apple is present. So here you can see mango is at 0th index, banana is at index number 1, apple is at index number 2, watermelon is at index number 3, again apple is at index number 4, and orange is at index number 5. So basically, apple, this value is appearing twice in this array and the corresponding index numbers are 2 and 4. So basically for apple, if we search for apple, we will get it in 2 indexes. One is 2 and another is 4. These 2 indexes are our answer. So if we want to search for a particular element in an array and we want to know at which indexes this element is appearing, we can use this method, where, np.where. So basically, np.where method will give us the opportunity to get the index number of a particular element or index numbers of the particular element if it is occurring multiple times. So here, what is the condition we are applying? This is fruits array, which is having these elements. And we are applying the condition np.where and we are adding fruits equal to apple. So wherever the fruits equal to apple, those indexes should be returned and will be assigned to this variable x. And if we print this variable x, we will get the result, which is nothing but the index numbers or array of index numbers where this condition is satisfied. So let us run this code and check what is happening here. So our expectation is we will get these 2 index numbers where apple is appearing in this array, which is nothing but 2 and 4. So let us execute this. And here we go. We are getting a tuple. Here if you see, x is a tuple where there is one array as the first element. And we are having these 2 values, 2, 4. So we can also see what is the type of this, what is the return type of this result. Let us see what is the type. Type is nothing but tuple. And if we loop over this, we can check the type of each item and the item itself. So let me just add some understandable messages over here. Okay, let me run it. So here you can see we have only one item in this tuple. The type of this X is nothing but a tuple. This is the entire value. And if we look over that, we can see each item type is nothing but ndarray. And item, as there is just one item, we can see the item value is 2, 4, which is nothing but the index numbers of this element which we were searching for. So basically what it does, it will take out or it will return all the index numbers wherever this condition is being satisfied. Now, let us move into another example. This is non-numerical. These are the non-numerical values. These are string values. We will move to a numerical example. So here we are having another array where we are having these values 1, 2, 3, 4, 5, 4. Okay. And these are the index numbers 0, 1, 2, 3, 4, 5. So there is a mistake over here. Fix it. If I want to search for this value 4 in this array, these are the indexes. So in this array, if we search for 4, wherever we are getting it here and here, these two places, correct? So basically, these two are the matches. And if we search for 4, then we are getting it. Where we are getting it? We are getting it at let us search for the result where we are getting it. So tell me, this 4 has an index number what? And this 4 is having another index number. So what is the index number for this 4? Is nothing but 3. And what is the index number for this 4? It's nothing but 5. So what is the result? The result is 3 and 5. So that I will put here is 3, 5. This is our expectation from this operation. So we will search for 4 in this array. So here we are having this array 1, 2, 3, 4, 5, 4. 1, 2, 3, 4, 5, 4. I'll remove this part, this extra. So if I execute this one, where we are checking the condition with where error equal 4. That means where this condition matches, wherever it is 4, it should return the index number. That is index number 3, 5 should be returned. So if we just execute this, that's where we are getting here 3, 5. So these are the two index numbers. At index number 3 and index number 5, we will be getting this value 4. So this is how our search works. So in this search condition, we can also add something apart from this equal. So here we are just putting equal condition and we are specifying the element we want to search for. But we can also have some different type of conditions or numerical expression here. Just let us move into the next example to see the same thing. So here we are having one array which is having these numbers 11, 62, 30, 41, 5, 63, 71, 82. Now, we want to search for only the even numbers. Okay, how we can do that? So even numbers are actually divisible by 2, right? So we can see here 62 is an even number, 30 is another even number, 41, 5, these are not. This is another even number. So basically, we are having even numbers as at these 3 indexes, 1, 2, and 7. That's why we are saying this should be the result, 1, 2, and 7. Correct? So at these 3 indexes, we are seeing even numbers here. These are the 3 indexes. Now, if we see how to do this. Let's see. So this is the condition we are going to specify for even numbers, because even numbers are divisible by 2, perfectly divisible by 2. There won't be any remainder. There won't be any remainder after we divide the even numbers with 2. So that is why what we are doing here is ARR modulo division 2 or remainder division 2 should be giving us 0. So if this condition satisfies, then only return the index number of that element. If we execute this one, we should be getting 1, 2, and 7. Let us see. That's what we are getting, 1, 2, 7, because these are the 3 indexes where we are having index number, where we are having even numbers, 62, 30, and 82. So that is how we can add some numerical expression also to perform our search. Next one is, so all of these we were talking about single dimensional arrays, NumPy arrays. Now we need to talk about the 2-dimensional arrays. What about 2D arrays? Let's have a look into that. So basically, if this is one of that which we are considering as a 2D array, let's say this is a 2D array. Okay, this entire thing is a 2-dimensional array where we are having total 16 elements. And here you can see these are the index numbers. These are the index numbers. Okay. These are the index numbers. These are also the index numbers. So if we consider it as row versus column, these are rows and these are columns. So basically in 2D array, we have already seen in the indexing lesson that we actually denote the indexes in this format. First the row number and then the column number. Correct? Or the value along the axis 0 and axis 1, like this. Now, if we consider this situation, search for 0, okay? We are trying to search for 0. So which are the places where 0 is present? So let me just remove this so that it is more visible. So which are the places where 0 is present in this array? This is 1, correct? This is another, and this is the 4th. So there are 4 zeros present in this array. And what should be the index number for this 0? So if we see, the index number for this 0 is nothing but row number 0 and column number, correct? So that is why you can see that we have put 0, 2 here. So 0, 2 is for this 0. Next one is which one? Next one is this one, where row number is 1 and column number is also 1. So this is the second 0. That is why here you can see 1, 1. Third 0 is what? Third 0 is at this position. So here also row number is again 1 and column number is 2. Correct? So this is at 1, 2 position. This is the index. And for the last one, again row number is 2 and column number is again 2. So this is 2. So this is the expected output we should get. This is the output we are expecting to get when we search for 0 in this array. Correct? Now let us move into the code and see how it works for 2-dimensional array. So this is a two-dimensional array where the same array you can see here is being defined by this one. Now we are calling this np.where and we are passing this condition arr equal to 0. That is arr should be equal to 0, then only return the index numbers. Now this x, let us see what is there in this x. Let me print it. And here we go. We can see now, again, x is a tuple, but it is now having two elements, two arrays in this, two ND arrays. So basically, previously also we saw that x was a tuple, but it was having only a single element, correct? So if we just print the type of x as well as we loop over these elements, what we can see here. Here you can see x is a tuple with two elements, which are two n-dimensional arrays. And here you can see this is a tuple. Basically, the type of x is tuple. Now, if we iterate over the x, we can see the first item here is an ND array and it is having four values 0, 1, 1. And the second ND array is having four values 2, 1, 1. Now, what was our expectation? Our expectation was 0, 2, 1, 1, 1, 2, 2, 2. That is what we can see here. Actually, it is showing the index over each axis. The first one is for axis 0 and second one is for axis 1. So here you can see 0, 1, 1, 2, which is nothing but the values for each of these first thing. So this 0, this 0 you can see here, this 1, and this 2, which you can see here as 0, 1, 1. Again, the values over the second axis, which is 2, 1, 1, 2, 1, 2, 2, that you can see here in the second array, 2, 1, 2. So this 0, 1, 1, 2, 0, 1, 1, 2, and 2, 1, 2, 2, 2, 1, 2, 2. These two are actually the index over two different axes. Now we have another option to visualize this in a better way, which is zip method. If we zip this two arrays into a single array, so what it will do, it will take 0 with 2, 1 with 1. So first element of this first array with the second element with the first element of the second array, then second element of the first array with second element of the second array, and so on. It will be zipping it. So I'm just printing it in the zip format so that we can get the exact output we were expecting from it. So here you can see, now we can see it in the correct format. Regarding the zip operation, I have already discussed it in the basic Python series. So you can definitely go and check it out to understand this better. Now let's move into a three-dimensional array and see what is happening here. For a three-dimensional array, again, the same thing will be returned. So let me just print it to show you. The result will be distributed over different axes. So for this particular example, what we are doing, what we are trying to do or achieve is that this is the array, and from here we are trying to get all the multipliers of 7 or all the multiples of 7 basically. Whichever values are divisible by 7, we are trying to get it out. And by looking at it, we can see there are only two such values which are divisible by 7, that is 7 and 14. So let us see what it is returning by executing this. So it is returning a tuple of 3 arrays, 3 ND arrays, and each of the arrays are having the index numbers along each of the axes. This is along axis 0, this is along axis 1, and this is along axis 2 because this is a three-dimensional array. So if we just print it with the help of zip now, first let me just iterate over it. You try to understand. These are the three values it is printing. And now if I just zip it and show you in the format we are comfortable to see. So these are the two index values it is returning. And let us just validate what are the values present in this index. So here I have written array and the index number this one. Let us see what value is present there. It's 7, correct? And if we see this index number, what is present here? This is 14. So it is actually returning the correct index values wherever this condition is being satisfied. So that's it for today, guys. I hope you have enjoyed this video. We will discuss more on this ND array in the next video. Till then, keep learning, keep implementing. Thank you for watching.